Welcome to the world of concentration units. There are a lot of concentration units out there, so I think it helps to see the relationships between the individual categories. All right, we have some that are based off of moles, some based off of masses, volume, and then we got some hybrid sort of concentration units. One thing that really helps for figuring out how concentration units work is to see a theme between solute, solvent, and solution. Solute, typically we're referring to whatever we dissolved that is of interest, whereas solvent is usually the bulk of the solution. If you were to dissolve some salt, sodium chloride, into water, that would be your solute, and the water would be the solvent. The whole entire mixture is referred to as the solution. The reason why that's important is I want you to see a theme. I want you to see that for most of the concentration units, we are dividing by the whole. Okay, we're dividing by the whole thing. See, for molarity, yep, there it is. Mass percent, parts per million, parts per billion, it is solution, solution, solution almost every single time. And that's what I want you to walk away with this video is usually when we're calculating concentration units, it is part divided by whole, the part being the solute. The only time that we have a denominator, a bottom of the fraction, that is the solvent only, that is with molality. Okay, that is the only time we have solvent as the denominator. All right, but otherwise, look, everything else is the same. It's solution at the bottom, and everything will have something about the solute at the top. Okay. Now, what's the purpose of all these units? Well, they're all concentrations. We're all trying to figure out how much of our substance is the solute of interest. Okay. So basically, they all do very similar things. There's times in life where it's more convenient to report in volumes. There's times in life where it's more convenient to report in masses. This would be like for water quality and maybe, looking at mineral, elemental percentages or something. You read a water quality report, you'll often see the contaminants listed in parts per million, parts per billion sort of levels. Okay. If you're doing something volume-based, maybe you're working with liquids, and liquids you measure easily in volumes, and that's maybe more convenient to work with on a constant basis. Okay. But yeah, they're all concentrations. The one category I want to pay particular attention to, though, is mole-based. Okay. In chemistry, we're often asked to do things on mole-to-mole bases, using mole-to-mole ratios. All right. And in order to do that, we call that stoichiometry, right? You're going to need mole-based concentration units. Okay. I'm going to argue that for most chemistry students or practitioners of chemistry, the molarity unit is going to be the most commonly used. The point of convenience of it over molality is that it measures the total solution, okay? Versus here we have to think about the mass of the solvent, and so we have to think of these two entities separately instead of as a whole, okay? There's maybe a handful of industries out there where molality is a more convenient unit of choice if you're adding masses of solvent or something, or maybe you're working in the solid state or something. But molarity, by and large, is the most common concentration unit in chemistry. It allows for easy stoichiometry. Because to be working in stoichiometry, you need to be working in moles rather than mass or volume or something. Okay. It is possible to do stoichiometry with mass or volume-based units, but you would have to first convert them to moles using a molar mass or something, and that's just a little bit more busy work, whereas a molarity is ready to go. Okay. So that's about this for the video. I just wanted a quick overview, and the next videos will be working with some of these concentration units individually. Thanks. Take care.